Let's see, this one tells me we have a simple random sample of 200 Utah children who are asked whether or not they like math. 102 are boys, and 41 of those like math. The other 98 are girls, and 29 like math. Is liking math independent of gender for Utah school children? When I look at this, I'm like, oh, they're talking about math, and they're also talking about gender. This is two variables. This has to be the chi-square test of independence. The chi-square test of independence is different because you don't have to go find your expected percentages, and you don't have to find your expected counts that way. Instead, if you remember, we did our expected counts was equal to our row total times our column over our total, or our table total, our overall sample size total. And so we would do that for each one of these cells. If you don't want to do it by hand, you can use the calculator. So you come back over here. Again, I will give you the link to this, but you go to Test for Independence. Okay. And now you can enter all of your data into this table, and it should look just like my table over here. So like I'm going to type in boys, and here I'm going to type in math, and here would be not math. Okay. And I actually don't need this third column, so I would do a minus, and it will take away that third column for me, or I could add in extra columns here if I need to. So I'm just going to pause and put all of my data in. Okay, so I made my table look the same way. You, again, do the plus and minus, the add or remove columns and rows. Make sure everything looks exactly the same, and then calculate. Okay, notice it will give me the raw data. That's the observed counts that I have over here. Then it will give me expected values. So I can tell you the expected value for math and boys. Okay, sorry, I hope you can see this cursor. So for math and boys that like math is 35.7. And then I can go down, and it has chi-square components. So I can tell you the chi-square component for boys that like math is 0.79. And I can tell you my test statistic equals this chi-squared equals 2.47. So if I was to draw this, here's my 2.47. I'm always looking for the area in the right, and it will do that for me. And it tells me my p-value equals 11.6%. Okay. It will even tell you your degrees of freedom. Degrees of freedom equals 1. Okay, because remember, we do our number of rows minus 1 times number of columns minus 1. And so it did all of that for me, and these are the results that I get. Okay. Again, I just have to be able to put it in, and I have to be able to interpret it. So I would say, oh, once again, this is a big p-value. So I would fail to reject the null, and I would say not statistically significant, and I would say no evidence that gender and liking math are associated. Okay. And we said that they're not associated, they don't seem to be affecting each other. But down here, does it tell you whether boys or girls are more likely to like math? The answer again is no. All it's going to tell me is whether or not they seem to be associated, whether or not they seem to be affecting each other. It won't actually tell me which one likes them more, at least not the test one. You can maybe use logic, but the test itself doesn't tell you any of that. Okay, next problem. It says, use the data in the table to see if belief in an afterlife is independent of race. Notice, keyword, independent. So this has to be the chi-square test of independence. Okay. Also, two categories or two variables, belief in afterlife versus race. So two different variables and things we're looking at. It has to be that chi-square test of independence. This one, I don't even have to do any work by hand. I can just go straight to the test. Okay. But first, let's write my null and alternative. Okay. The null would be that, let's see. So the null is that race and belief are independent or not associated, do not affect each other. Sorry, I have a really tiny keyboard. And my alternative then is that race and belief are dependent. Okay, they are associated or affect each other. So we hesitate to say affect each other because we don't like to say cause and effect. Okay. However, that's what dependent means, that they affect each other. But so sometimes we like to say associated, meaning that they tell us information about each other, even if it's not a cause and effect relationship. Okay, so coming back up, you'd go back to your starting link. So you'd go to the calculator, you'd go to the test of independence. Okay, and now I just need to put it in. I have too many columns, so I'll just do a minus and get rid of my column. Okay, and I push calculate. Sorry, I did that a little too fast. Okay, let me go back. So there's this thing to edit data if you realize you messed up. So coming back, look at it, double check all of your numbers. Now calculate. So your raw data is your actual counts. Okay, then you have expected counts. Okay, so we'll give you this expected. So we could say like expected for white and yes, and I can tell you expected for white and yes is 616.15, just in case you got asked that. And then I'll tell you the chi-squared component. Okay, so scroll down. One thing you should do, I didn't have totals listed here, but double check that the totals on your expected counts are the same as the data I gave you. That's one way to double check if you put something in wrong. Okay, and then chi-square components, that observed minus expected squared over expected. I could tell you for white and yes, it is 0.04. And then I can keep going down, so I can tell you my test statistic. Chi-squared equals 1.02. I can tell you degrees of freedom, it just tells me right there is 1. And my p-value, well, as always, you take your curve and you say, here's my test statistic of 1.02, and you're looking for the area to the right. And it tells me that my p-value is 31.24%. I don't know why every example on here had big p-values, but now I can type up my results. And so I would say that is a big p-value. So big p-value, I would fail to reject the null, and we would say no evidence that race and belief are associated or dependent or affect each other. Now, we said there's no reason to believe that they do affect each other. Even if we had gotten a small p-value, though, all you can say based on this hypothesis test is whether or not race affects belief in an afterlife. You can't actually say which race is more likely to believe in the afterlife based on the test. You can maybe use some logic, but the test itself doesn't tell you how the different categories affect each other.